Welcome students. Today we have a discussion about the question which is asked regarding chemical evaluation or chemical method of standardization of herbal drugs. They have asked, but in handout we have gone for a detail one chapter itself, but we will make it very short, and I am not going to give the full details, but something new which the students should know. I have taken some video. We'll see that. Here the question was asked to explain WHO guidelines for chemical evaluation of herbal drugs. So, in which we are concentrating today. Here, even only I want to give some definitions which is already given in the handout. That is, WHO has given certain guidelines for the assessment of herbal drugs in most of the country, and they are adopting these guidelines. And the aim, what is the aim of this WHO giving these guidelines? You can see that quality control of crude drugs is very important for the materials which is used in different parts and different manufacturing procedures. And plant preparation and finished products also should have some limit. And stability assessment and self-life, which we mention about the expiry dates of any products, how long it can be stored and how long it can be used. These all things comes in this. And safety assessment, documentation of safety based on experience or toxicological studies, and assessment of efficacy of studying pharmacology of drugs and evaluation of biological activity. This is simply starting, and you can see this picture which is already given to you in your handout. I am explaining only this slide and going for certain important explanation which is not present there or given explanation before. So here it is divided into 5 parts: organoleptic, botanical, physical, chemical and biological. Organoleptic, we know that color, odor, taste, texture, fraction. These all things you have done in your lab practical works. So it is necessary for the students to explain them if they ask detail about standardization of quality, evaluation of herbal drugs, guidelines given by WHO, means you should explain clearly. And next come the botanical. In botanical also we have done lab so that you can remember microscopic, like shape of the drug, external markings of macroscopy and microscopy sections, LS, TS, RLS, and quantitative estimation, and also that is scanning of electron microscope, enlarged pitch, finding out, and powder microscopy, identifying the drug by means of adulterations. The evaluation can be done by microscopic method. Physical method, next one, if we see moisture content, extraction value, ash value, fluorescent analysis, that means material of fluorescent material can be mixed up, and microscopical identification of their various compounds, and even it includes many methods. fluorescent analysis for the compounds which is having fluorescent compounds also can be done. And I just made this foam index and swelling index in the physical evaluation, because previously it was shown in the pharmacological subdivision in standardization of herbal drugs, and it can come even under chemical, but it's more interesting to bring them in the physical evaluation, because we have done this lab. In the lab you have done foam index, swelling index, so you can write even the procedure if they are asking in detail. And coming to the chemical evaluation, today we are going to deal with the chemical evaluation in detail. In that, particularly only one or two of them I am going to include specifically. And biological evaluation is also, you can see, pharmacological evaluation by means of finding out bitter value of herbal drugs, hemolytic activity of herbal drugs. Why? Pharmacological activity of herbal drugs can also be identified. Various, why we are not mentioned, because you know that there are many pharmacological action, starting from anti-inflammatory to antipsychotic. We can be identified by means of animal model, we can test it. And toxicologically determination of various pesticide presence and various heavy metals, lead, tin, why not zinc, sulfate, many things, heavy metals, even heavy metals also, arsenic, presence, limits can also be identified. This all comes in biological. And when you come to microbiological, contamination is also very important work which have to be done, like total viable microbes present, aerobic content, or determination of pathogens present, aflatoxin content. These all are some of the very important procedures which you have to study and you have to write if they ask about biological evaluation procedures to maintain the standard which is given by WHO. Now we are coming to detail about the question. What they have asked is chemical evaluation. In chemical evaluation, it's very important for you to know about many things, because students who have completed their degree, most of them, they will be interested to go for analytical lab or to the industry, and some of them they may go for research, they may go for PG. So all of them, you should know about chemical evaluation, how you perform, not only for herbal drugs, even for other normal tablet, capsule, syrup, orals, injections, anywhere, wherever, vaccines, anything. If you want to do, you should know about all the operations of instruments and how to perform this chemical evaluation, standardization of the drugs. So here I have made that is quantitative and qualitative estimation by means of chemical evaluation is a very important one, in which we have studied and we have done lab by means of chromatographic method. So students may be knowing very clearly what is chromatography and what is chromatographic methods. Various methods are present. TLC we have done, and paper chromatography we have done. That is a basic thing which we should know. So what is that? What is the prime? What is the stationary phase? What is the mobile phase? How the separation takes place? What is chromatography? Chromatography means a technique which can separate the mixture of compounds. So there are many basic principles. Basically they have two. One is adsorption and one is partition. All these things we have done very clearly, and you can go through that very detailedly, and it will helpful for you to understand and to write in detail. So now we are going to think about what is HPTLC fingerprinting. What is how to secondary metabolites identification by this method, quantitatively, qualitatively. And DNA fingerprinting means what? Simply writing, it's not good. Actually students might not have known what is this fingerprinting. What is this DNA fingerprinting? What do you mean by this HPTLC fingerprinting? You should know that, so that you can write in detail. If you see a video of that instrument, and if you know the instrument in practically, so that it will be easy for the students to write in detail. That is what my aim to come today to detail to give you about the chemical evaluation of standardization of herbal drugs given by WHO. And chromatographic techniques, you know that HPTLC, GLC, gas chromatography, HPLC, high performance liquid chromatography, and radioactive contaminations can also be identified by means of chemical evaluations, by means of various radioactive identifying instruments, and also you can go for using various markers. This all comes under in chemical evaluation. So now we are, as I told again and again, two things I am going to show you about the HPTLC fingerprinting. What is HPTLC fingerprinting and what is meant by DNA fingerprinting? When you see this and when you know this two, it will be more than interesting and sufficient for you to give you detail, and it will be helpful for my students to go for in their future research as well as to future job and future many things. Because you know, HPTLC is not present in our college, and it's in future they may be bringing to you. So anyhow, if you see this video, you may be knowing, because you have done already TLC. Remember TLC, how we are prepared a thin layer of plate, and how we used a mobile solvent, and how we made developing the mobile solvent, and then we went for, first before that we should know spotting of the sample, and then we are developing it by means of in a developing chamber using a tall beaker. We developed, and then we just go for detecting solution spraying, and then spot identification by visual. In theoretical you might have seen by means of even go for UV chamber, and then finding out the RF value and identifying the particular sample with comparing with the reference standard. So the same system will be used, but it will be sophisticated when you go for HPLC or HPTLC or even fingerprinting of DNA using electrophoresis, gel permeation chromatography. These are all chromatographies you might have studied in chemistry. So in detail you just go for, it is a very important technique. Chromatography is a very important technique which will be useful for you in future and wherever you go for any job or anything. So here we are just going into that HPTLC, high performance thin layer chromatography, is a powerful analytical technique which is wonderful, suitable for quantitative and qualitative. Amount can also be identified, and directly it is connected with system. And analytical tasks can be easily identified. And development of chromatographic fingerprints plays an important role in quality control of complex herbal medicine. Here I have mentioned one ADC. Some places they may be using ADC, means analog to digital converters. For example, an instrument will have some sample. When you keep, it will be digitally converted to the computer, and so that you can read. That's what in many places they used to see ADC in their procedure. So just I have mentioned that it is an abbreviation. You should know that. Now we are going to that video which I want to show you. See here, in this sketch, ginkgo biloba is a sample which we are going to identify. Here what all the things which we want to do is sample preparation of analysis, sample application. So first sample preparation from your extract. For some your herbal drugs, you have to prepare the sample, and it has to be inserted into the particular instrument. Automatically they will prepare for the analysis inside the instrument. You can see the video. First, if you remember this, sample application, we are not applying. You remember how we applied in the TLC? We took one capillary tube and we applied to make it a minimum of single spot. But here it is a minute, very minute, micro ml. Even the amount can be determined. It will be done by the instrument. You can see the video and you can see very sharp, and the sample will be automatically applied by the instrument in the chamber. And development. You will develop in the thin layer of plate. High performance it is. Not like thin layer plate which we prepared. It is automatically very thin and a standard uniform. And after sample application, it will be developed by the solvent, mobile solvent. and then it is documented. Understand? By means of the chamber can identify in visual. Spots can be easily connected with computer. Data can be easily taken as a printout. And derivatization. After the plate is again derivatized, made by means of using some herbal or natural, usually detecting agents, and then dried and the spotting, and then again documentation. So we can find out this documentation means what? What we did, there R and RF value. Here it was little more in detail about the RF values can be seen. Now you see the procedure, how they are doing. Sample. How to prepare sample preparation? Weigh 100 milligram of the sample extract and a reference sample also. Reference, it is not, it's completely blocked by means of the video. You could say reference sample and reference, or sample and a standard. And as a standard, which compound which you are interested to find out whether it is present or not. Both 100 milligram, an addition of 10 milligram, addition of 10 ml, not milligram, 10 ml of methanol, high grade quality, HPLC grade quality methanol is used. You see the madam is just preparing a sample, she's weighing in a digital balance and as 100 milligram, diluting with methanol, you see high grade methanol, Jingaco extract. And how is she going to prepare sample, you see? Here, you see, very important, listen, this, why I am putting pause means you should know it should not go, because simply if you watch a video, it is no meaning. You should know what is going on there. Sample preparation, what are the things needed? That is sonication for 10 minutes. What do you mean by sonication? Sonication, that means ultrasonic waves will be used for solubilizing. They will keep the tube in the ultrasonic vessel in a liquid, the test tube. It will solubilize by means of the ultrasonic waves moving inside the liquid. And then centrifugation, that you know, centrifugation. You might have done in APH for urine sedimentation to identify. So centrifugation machine can be used for 5 minutes with 5,000 revolution per minute, and then transfer this solution to the vial of sample vials. When you see the procedure, when you see the video, they might have done solubilizing in ultrasonic waves in a vessel, in a bath, ultrasonic bath, and then they might have taken to vibration also. They are doing vibration instead of shaking with the hand, vibration using a machine, and then they will go for centrifugation. You see now, what she is doing is, say, she has, before that, just a minute, this is, she came to centrifugation. Before centrifugation, you should know, this is ultrasonic. See there? Ultrasonic. After ultrasonic, she keeps it in the vibration. This is the vibration. After vibrating, she keeps into the centrifugation machine. See that? That's what, 3 steps. And centrifugation. In centrifugation, she kept for 5,000 RPM. Then she brings that supernatant liquid. She's using, see, in the small, she's having a small vial, sample vial, and using a micropipette, 20 micro ml, very little, uniformly the supernatant liquid of the sample is taken. Sample and standard will be loaded. Now she will be going for the loading. See, she is sealing with an aluminium cap and then sealing it. That is sample. And it will be labeled also. And this labeled sample Now next step is preparation of analysis. Sample is prepared, loading and executing the vision of CAT method, that is the method which is they are following, and filling the sequence table, labeling. You should write. If suppose you are using a plate for HPTLC, you should write it. What is the sample which you are using there? And then after that, before spotting or before developing, you should capture the plate. You should keep inside the chamber and it will be converted into digital and you can see in the screen of the computer and it will be saved. And that will be taken in white light, re-emission, transmission, and then UV light in 254 nanometer. It will be recorded. After developing, you will take another one UV radiation, 366 also you will be taking. So now we will be taking 2 pictures before developing. Now we can see that first you have to enter in the computer. See that in the computer itself you will get the icon, all the icons. The developing chamber, sampling area, all these things. And first you can see you have to write down, you have to type all the details. Here she has taken ginkgo extract and she is writing that what is the quantity, what is the amount, and what is the standard she has taken for comparison. All these details she has to enter in the computer, which is connected with all this HPTLC, that means high performance thin layer chromatography instrument. So everything will be connected. Now she is writing the plate. See, she is writing. This is what I told you. She is writing in the, she is making, she is noting down before sampling. See, for example, we'll come to see what she is doing. She's just here. I want to put the pass to note it down. She's just making the mark. This is the ginkgo sample because they will be doing daily many samples. So she's writing as we used to write. I told you, you should write the name, you should write the date, you should write the batch. Like that I used to put the signature. Do you remember the lab for a paper chromatography? Same thing here also. This is HPTLC. So she's writing the sample's name in the plate. And first what she's doing. Now she's going to, without developing, she's taking the plate, and in this is the chamber where the picture will be transformed to the computer. You see, immediately it is installing and shows the picture. See, this is the, it's just scan and you got the picture. And now after taking the picture, you are going for sampling. Fix that plate in the slot which is provided. You see the sampling, not by capillary tube like what we did. You have to select in the computer and you should say that I have kept for sampling. You see the instrument, already loaded the sample reference and the sample have been loaded inside the instrument and it is just making a small, very small spot, minute spot. And after spot, ADC means transferring to the computer. Now we are first, you are rinsing it. You see what all the things you have to do. See here, I didn't mention this. You have to just keep on, just we will go to the reading and then afterwards if you see this video, see first what it is written, you should rinse. So first she is rinsing it. They said to rinse. So she is using for rinsing to clean both the place. One is for developing solvent, another is for saturation. Saturation also very important. Understand, saturation. For saturation only. See, for example, here you can remember this one. Sorry. See here, after this place, development, you should develop, that is humidity control 33% and reproducing area, the atmosphere for the filter paper, and a filter paper will be there inside the chamber, which is also impregnated with the developing solvent, and 10 ml for developing solvent and 25 ml is for the chamber saturation. So they have two places where she was rinsing. The same two places will be shown now. You just see. In one place she will add 10 ml, and this is the chamber she is keeping inside, and there is some filter paper inside the chamber also for saturation. So first you see she is taking 10 ml. Sorry, 25 ml she is taking, 25 ml. This is for, in that corner she is pouring, it is for developing solvent system, mobile solvent. It will come down. Already it has come down. She poured there, it has come down. And this is 10 ml. This is for saturation. It will go to the filter paper which is present there, white color. And it will make saturation of the chamber. Now she is keeping the plate. Already sample have been spotted, fixed there, and she is keeping the plate in the top place. And you may think it is in the top, but when she closes, it will come down to the chamber. Automatically it will come down. Now she is operating from the computer for the developing. See, she says continue for developing. You can see the picture, the icon. What is happening? The plate came down, it is developing. And it gives you indication automatically. It is high performance liquid thin layer chromatography. It gives indication for you. And after it is finished, it shows finished. Development process is over. Then you have to take OK and remove the plate. Remove the plate. Remove the plate now. From the holder, remove the plate. And you see here, this you have to remember. What it is written? After removing the plate, documentation of the plate development. What all the documentation you are going to see? You are going to keep the plate in a chamber where the picture will be taken in three forms. One is by light, re-emission of transmission, white light, re-emission transmission, white light. And second one, a light will be focused on this plate, UV radiation with 254 nanometer. So the UV absorption samples will give you glow, a color that will be photographed by means of the computer. And next switch they will put, and immediately it will take another photograph of this plate in UV 366 nanometer, and you can see in the system. So remember, that's why I stopped here, and so that you will understand. So she is keeping inside the chamber, close it, and going for the computer and taking the pictures of the three. First one is she got from white light. Second one is she got from UV. Third one is also, this is from white light she got like this picture. And this is from UV 254 nanometer. And the next one, this is from UV 366 nanometer. Understand? So three pictures have been taken. And now she is going for, next step is derivatization. So what do you mean by derivatization? She takes this plate, she got all the spots, details by means of the first documentation. And second, she is doing derivatization. What she is going to do? She is going to heat it at 100 degrees centigrade 3 minutes and dipping the plate in natural product reagent. A natural product reagent. I am not going for detail about that reagent. When you go, one detail, it will widen. Understand? Just detecting a reagent. And then you have to dry in a cold air or a dryer, cold air dryer. And again you have to dip that plate in polyethylene glycol 400. Polyethylene glycol 400. How you are doing? It will make glassy and it will fix that spots very clearly. And again dry it in cold air and go for your picture, your detection and documentation. Understand? That is what we are going to do here. And now you see the video what we are. See, it's kept there, heated, dried. After drying, that's also, it will say, okay, it's dried. 100 degrees dried. And then she fix it, dips in the natural reagent. See that? She fix it. Automatically, it dips in the natural reagent. What a fantastic instrument. And then she comes to the drying area. See that? You can give a dry. And again, in polyethylene glycol 400 dipping. And then again, you have to go for drying, which I have seen in the procedure. Again, dry. You got the spot very clearly. Now you have to go for documentation. Documentation. Keep it there. Get the picturized in the computer. For white light, you will get the picture. And for UV light, you will get the picture. See the spotting. Here for white light, re-emission. And this is for UV light 366 nanometer. The spots all are received. And now you can identify the result in HPTLC. And very clearly you can derivatized plate, all the derivatized plate of the second plate, and you can compare it and you can finish your work. I hope something is better than nothing. At least I have given you some idea about HPTLC. Please just have an idea. You can write something about HPTLC, not only for herbal drug technology, even you can write in your other subjects in analytical chemistry or in your modern method of analysis also. You can go for little more in detail by means of this knowledge. You can elaborate it. And now one more video, just one more video. Please be patient. Please be patient. I felt that I should not take more time, but I don't know. My explanation becoming little, going little stretched. Anyhow, we'll go to next immediately because this is also very important, which I want. DNA fingerprinting. Most of the students, they may not be knowing about what is DNA fingerprinting. Because DNA fingerprinting is have application in herbal drug technology and herbal analysis according to WHO. Even when you identify, when you go for any research or any type of research work in herbal drugs for your future pharmacological activity also, you should know this DNA fingerprinting. So what do you mean by DNA fingerprinting? Barcode-like pattern generated by amplification of chromosomal DNA of an individual, which can distinguish the uniqueness of this individual from another. And you see, also called DNA typing, genetic fingerprinting DNA, profiling the DNA typing. You see, DNA fingerprinting, important tool in herbal drug standardization, useful for the identification of genuine, whether it is adulterated or not, purity, standardization can be done, or substituted or adulterated can be easily identified. DNA fingerprinting genome remain the same irrespective to the plant part. Which part can also be identified, whether it is from the flower it is taken or root is taken, that is also can be identified. Using, while the phytochemical constituents will vary with the part of the plant also. So DNA sequence are highly specific. They are highly specific and can be identified with molecular markers which can find out a particular sequence of DNA from a group of unknown. What a fantastic technology it is. So you should know that what is DNA fingerprinting. That's why I have taken a video to show you. It's also having connection with the, you have studied about gel permeation chromatography, gel, what is that? You should know. This is the application. They have given application for this DNA gel electrophoresis. It is also a chromatographic technique, electrophoresis, by means of electric charge. Separation can be done in the gel. Understand? Can you follow this? So that's what. You can see the DNA molecule are separated on the basis of their charge. DNA are negatively charged and their size. As the concentration of agarose, we are using agarose as a gel. Agarose gel, it will move through. So agarose increases the size of pore, will decrease with vice versa. Okay? The DNA. So therefore, the large molecule cannot run faster. Even we know that a large molecule cannot run very faster in comparison with the small DNA fragments. So that is a technology which they are using it for chromatographic separation. The smaller fragments appears near to the positive charge. It will run faster to the near to the positive charge. Understand? Migrate faster towards the positive mode. Consequently, once the electric current is passed through the gel, the DNA starts moving towards the positive electrode. It's small means run fast. Larger molecule, slowly. DNA is already a negative. So it runs towards the positive charge. Very simple for understanding. Understand? A tagged fluorescent, now we are going to, after getting this separation, they will use one, same like in chromatographic, developing solution. Here in developing, what you are doing? Ethidium bromide. A fluorescent ethidium bromide dye will be poured on it, gel. Using a visualized DNA band, it will make a visualized DNA band. Another dye named DNA gel, there are many dye, and you can loading dye monitors the migration of the DNA, can also be studied by running ahead to it before that. And furthermore, a known molecular weight DNA markers is used to calculate the exact DNA size. These all studies can also be done. But here in my video, I have shown about the electrophoresis, how a DNA molecule, how a two DNA molecule is compared by two samples, which they are similar or which there is any difference, they are belongs to the same or not, can be identified. That's what I have taken. This is just one, is to give the details about that ethidium bromide is a developing fluorescent fluid which is used in this electrophoresis, DNA fingerprinting electrophoresis technique, or it can also called as homadium bromide, chlorine salt. Homadium chloride can also be used, is an intercalating agent commonly used as a fluorescent tag nucleic acid strain. It is also called nucleic acid strain, which can identify the DNA molecule. A molecular biological laboratory for technique such as agarose gel electrophoresis. This video which I have taken is agarose gel electrode, which will show you very clearly. Here, this researcher is preparing a sample, same like what you have seen in the last video for HPTLC. Understand? This is electrophoresis, and here he is preparing a sample and using an enzymes. You know, enzymes are responsible for dividing the separating the DNA. So how much the DNA molecule is more, that much you can get the different parts, separation will take place. So here, this researcher, you can see he is taking various enzymes, and first he is preparing the agarose. See, agarose is a jelly formation, dilute to and heat it by 116 degrees centigrade, not more than that, and it is a liquid form. Pour it in the hot condition to this plate where the gel is formed. And there is one, see, there is one, he is taking out. Can you see that? Just I will put the pause. Before that, you can see there is one plate which is he is removing. What is that? It is kept in the gel itself. Gel is solidified. Agarose got solidified, and it is a plastic like a comb. There is lot of pointed. There is lot of gap with like a teeth. So that will be removed. Once it is removed, you will get holes. You will get wells. That is called wells, which is ready for filling your sample of DNA sample with enzyme should be filled there. Understand? It should be filled there, and there will be two electrodes will be there. One will be in a negative, another will be positive in the same plate. That's what you have to see. That simply video it running you cannot understand. That's why I stopped here. Just watch. He removes, and you can see the wells. There is two knobs. This is a negative side, and that is a positive side of the electrodes. And he removed the plate and he fixed there. That is the place where he before that is how fixing. Before that, a sampling should be done. Exact amount in the holes, the wells which I have shown there. This is the micro pipette. Once you press it, it will take the solution from the sample. And then again when you press hardly, the lid can be removed. It should be changed for each and every sample. DNA, you have to be very careful. He is taking from the sample and filling the well, the holes. I told there we made a holes. He's filling the DNA sample in all the wells. You see how he is filling it. And every wells, it should not split out. And then you have to keep into the solution, the ionic solution. Your work is over. Close it out. And keep it 100 volts for 30 minutes. 100 volts for 30 minutes. Electrophoresis, the movement of the separation of the movement of DNA towards the positive electrode. The red is positive electrode. Towards the positive electrode will take place inside the gel. Inside the gel. And after 30 minutes, take out the gel. You can see the gel movement, as I told, the separation after taking place. Same like what you did in the HPTLC. Remove the plate. Go for picturizing. Take the gel out. And now pour the detecting solution, which I told, the bromine. That is etherium bromide is just poured. Got the picture. And you see here, this is the picture from the gel which you got as you got in the HPTLC. We have kept inside that instrument and we have picturized after this detecting solution is poured over it. So, you see here 1, 2, 3, 4, 5, 6, 7, 8. Well, there is no DNA is not present. But here these all of them are different DNA. And you can see that experiment they have got a suspicious which one is similar. You see the second one and the fourth one. Second one and fourth one DNA molecules, they have been picturized similarly. They have shown their values similarly. They have shown their identities similarly. So, it became very simple for you to say, this sample and this sample are from same DNA molecule. They are from same part of the plant. Or if you are going for some other study, you can say, it belongs to the same person. This is what fingerprinting, DNA fingerprinting by electrophoresis method. Thank you very much for the students. Please for listening. I don't want to make long time as I told, but anyhow, I'm not going to give any notes or because I don't think students are much interested to take the notes or anything. I think just if you are interested, any doubt you can ask in future and you study well. And this is the two things which I want to explain today, and other things you can add and you can increase your knowledge in other sections. Understand about this question. Thank you for this class.